All right. Happy Friday, everybody. We're getting close. We're at the halfway mark here. We're doing block 10. That was Todd Rudgren with Bang on the Drums and Great Friday song. And we're going to go through block 10 and try to look at some of the things that are going to be required. So if we go in, so it says we're gonna go along and look at this example, which I detailed um, in block 9 pretty heavily. There's also a couple of sources that Jason put in from our good friend Tim Maring, who's also from Wisconsin. I worked with him, so did Jason. Good guy. Um, I went through and used the uh, beam analysis shortcuts to to do this, so that you can see it. And then it says in your we're going to break into groups. And if your group is 1, 4, 7, we're going to focus on step 4. If your group number is 2, 5, or 8, we'll focus on step 5, and you could read the rest. So um, then you're all gonna create. Um, you're gonna create your own beam analysis practice problem and do some corrections in the PowerPoint. All right, so for the submissions, it says the beam design practice problems collaboration tool. Analyze the beams posted on the page just before and the page just after your group's beam diagram. Okay, document your work in your engineering notebook. Um, so it says here where we get into the beam analysis shortcuts, and I'm going to show you where they are in the formula sheet. They're on CEA page 4, POE page 5. They're right here. Right now, we're going to focus only on reaction force. I'm sorry, on the reaction and moment um, and max deflection and maximum moment. Okay, so but as you can see, when we go through to do beam design, we're going to be getting into some uh, heavy duty calculations. That will be Monday when we go into block 11. Okay, but I wanted to show you where this is in the formula sheet. So, and it says apply the appropriate beam formulas to check your group's beam analysis practice problem and verify, take a screenshot of the calculations, free body diagram. Then it gets into some reading here. Okay, so we talk about structural failure and why things happen like that, whether it be a frame, load bearing wall foundations, um, the the hotel in Kansas City where the second floor gave way, and or bridges that have collapsed. So, and we need to understand why those things happen, and we need to understand if they happen because of um, neglect or unethical situations, and so we need to look at that. Um, Here it says, analyzing structural failures can uncover poor or unethical decision making on the part of each stakeholder, and structural engineers have a duty to adhere to the highest principles, and that's a fact. Okay, so It says to read parts 1 through 8 as well as the addendum um, in the William Le Mesurier. For those of you that know French, I don't. Maybe you can tell me how that's pronounced. This is the 59 story crisis. The addendum is Diane Hartley case. So we're going to read about professional ethics, which is very important in engineering. Very important for the students to understand that there is an ethical responsibility. Um, that that is why we stress it is essential that they learn it. So we'll read that, and you'll be able to answer the essential question. 3.2, why do buildings fall down? How can we prevent future structural failures and such? And then, as far as the Keystone Library renovation, a rubric, you should go through that. You will submit evidence of your progress on this page, on submission form 11. So we should be uh, we should be moving along with that. Okay, so I'm going to show you real quick an example of beam analysis shortcuts that I did using that um, using this um, using this problem. Okay, um, concentrated load would be 500. The uniformly distributed load is 100. So you're gonna look to see, you're gonna look and see how much easier it is to do it this way. So here it is, beam analysis shortcut example. I have 100 pounds per foot. That's reaction force A on the left, which is, I'm sorry, I forgot to include the arrow going this way because it's a pin. And even though there's no horizontal forces, it's still important to show that. So I'm sorry about that. Make sure that you show it. I mean, this is a free body diagram. You have to show all the forces. And this is the pin. This is the fixed location. And this is the roller. So this has one reaction. This has two. Um, RFA-Y and RFA-X. So I was remiss to not put that in. I wanted to, reinforce that fact. Okay, so the shortcut formula for this, pretty easy because it's a distributed load across the entire length span of the beam of 16 feet. So it stands to reason that both RFA and RFBY are going to be equal. So in this regard, we can take the load of 100 pounds per foot times the length and divide that by 2. So we come up with 800 pounds. Okay, and then if we look at our shear diagram, we see that it starts up at 800 and goes down to 800, and our maximum shear is at the center. Um, the maximum moment formula is the distributed weight times the length squared. So we have 100 pounds times 16 feet squared divided by 8. So our maximum moment, therefore, is 3,200. And again, sorry for my not being able to draw very, very good parabola there. But okay, seeing that I didn't put those arrows in there, I wanted to I wanted to come back to this and show you that. So this is, again, this is a fixed connection, and this is a roller connection. So the roller has the one here, whereas fixed has horizontal force, a force in the x, and a force in the y. Okay, so when there's only one, and this doesn't happen often, especially those of you that teach POE, you should be um, well versed in this. Um, when you have other horizontal forces, you have to um, go in and calculate for those as well. When we do truss analysis, that's that comes in very handy knowing how to do that. But I just wanted to let you know about that. And then later on today, I'm going to talk about an example of a bridge I worked on um, in Avon, New York on I 390. I was working for New York DOT. We did a bridge with two fixed connections, and I'll tell you more about that later. Again, we're we'll after today we'll be more than halfway done. The last two or three assignments are 18, 19, and 20 are pretty simple. So we're after Monday. I think we'll be making a lot of headway. So with that, enjoy Friday, and let's go bang the drum.